Hello dear students, welcome to YourPedia. Today I am going to discuss a very good question that was asked in previous 2019 IOCL interview for electrical engineering candidates through GATE. Good question from the concept of power system stability. Okay, the question is yes, what are the methods to improve transient stability? What are the methods that are used practically to improve transient stability? First of all, what is transient stability? See, whenever a big disturbance occurs, then whether a system is able to regain its stability or not will be decided by transient stability. What is steady state stability or small signal stability? For small disturbances like load changes, but for large disturbances, what are the large disturbances? Practically faults, contingencies. These are the large disturbances. For those disturbances, if the system or the generator is able to regain its stable position, then the system is said to be stable. That is called as transient stability. Okay, what are the methods to improve transient stability, they ask. See, for that, first of all, to answer this question, one must have good idea on what is stability, then what is transient stability. Okay, then different equations of power system network. That is the first equation that we have to consider in your mind is a swing equation. Okay, yeah, let's see how to improve stability. What is swing equation? Swing equation, yes, what is a swing equation? M into d square del of t by dt square is equal to Pa, that is acceleration power. What is Pa? Acceleration power. Pa is equal to what? Pa is equal to Ps minus P. Pa is equal to Ps minus P. What is Ps? Ps is steam input, P is electric power output. Yes. So I am writing here d square del of t by dt square is equal to Pa by M. Yes, Pa by M. Okay. Now what is Pa? Pa is equal to Ps minus Pe by M. Okay. What is d square delta by dt square? Rotor angular acceleration. Now the first method to improve transient stability is design synchronous machine. Synchronous machine with a high capacity or inertia. What is the advantage if we design with high capacity? If the capacity is high, I can say this M increases, d square by delta, d square del of t by dt square will decrease. Yes. See, for a system to be more stable, it must have less oscillations, or it must have less acceleration. That is possible with high capacity. See, I'll tell you very simply. So the body which is having less weight is prone to be more making more oscillations when compared with the body which is having more weight. Yes, that is the first thing. Second thing is, by connecting a flywheel to the rotor body, flywheel is a huge mass. Flywheel to the rotor body. Yes, connect a huge body to the rotor body. Then what happens is, see, starting, yes, you may be thinking, sir, if we connect that much huge body, it is going to be burden on turbine. No. only in the starting it is difficult. Once it starts, yes, that flywheel is going to store lots of kinetic energy. Yes, that is going to rotate. Whenever any disturbance comes, that huge body which is already in running state or which is already in steady state will not accept those sudden changes. Therefore, your rotor angle or rotor is not going to oscillate about some point. That oscillations will be reduced. Okay, that is the second thing. Third one is, yes, third one is introduce damping. Introduce damping in the rotor. What does it mean by damping? Opposition for the oscillations. There will be damper winding. See, in the rotor body, you can keep damper winding to reduce those oscillations. That is also one of the method to improve transient stability. Yes, the fourth one is, yes, by resistance grounding. Yes, by resistance grounding. Yeah, I'll show you how this resistance grounding will improve stability. See, without resistance grounding, what is PA? PA is equal to PS minus P. See, with solid grounding, PA is equal to PS minus PE plus I square RN. Yes, this is with resistance grounding. With what ma? Resistance grounding. Observe here. Now, this is, I'll call this one as PA2, this one as PA1. PA2 is less than PA1. What is PA? Acceleration power. If acceleration power decreases, acceleration of the rotor will decrease. If acceleration decreases, stability will improve. Next one. Yes. By decreasing reactance. Yes. How decreasing in reactance will improve stability? Let us see. It's a very good thing. PA is equal to PS minus PE. Yeah, let me write. PA is equal to PS minus P is what? Mod Vs mod Vr by X into sine delta. Observe, if reactance decreases, then this total will increase, then this total will decrease. PA is decreasing. If acceleration power decreases, then yes, stability will improve. Transient stability will improve. Decrement of decreasing this reactance. Now they may ask you a cross question: how can you decrease reactance? How can you decrease reactance? So X can be decreased these many ways. First one is with a series capacitor. Second one is with bundle conductors. Yes. Third one is with parallel transmission lines. Yes. Parallel transmission lines. With parallel transmission lines. Yes. Parallel transmission lines. Few more are there. Yeah. Fourth one is with see, if you decrease the distance between the stator and rotor, means the air gap between stator and rotor decreases, then leakage reactance will decrease. Therefore, the total reactance will decrease. By designing synchronous machine, synchronous machine with low reactance. Yes, I told you, to reduce the reactance there are several different designs. How to design a tooth and slot to reduce reactance, you might study it in machines. Okay, and if you reduce the air gap between the stator and rotor, then leakage will decrease. Okay, next, so this is one of the method to reduce the reactance. So these many methods are there to reduce the reactance. Okay, now reducing reactance is one method to improve stability. So the fifth one is okay, yeah, I took, yeah, this is for general 4 only. Yes, so the fifth method to improve stability is by using AVR, automatic voltage regulator. By using automatic voltage regulator, what it happens, what it will do, PA is equal to PS minus P is mod Vs mod Vr by X into sine delta. What happens is, whenever fault occurs, this PE will decrease due to fault, that PE will decrease. At that time, by using automatic voltage regulator, we will increase this Vs. If Vs increases, obviously this Vr also will increase. Then this total part will increase. Then this entire will decrease. That implies, yeah, you can observe carefully, So PA is decreasing. If PA is decreasing, stability will improve. This is one of the method. Yes. What is another method, ma? What is another method to improve stability? Yes. So there are several methods to improve stability. This one is one of the very important one, that is using a single pole circuit breaker instead of 3-pole circuit breaker. Using single pole circuit breaker instead of, yes, 3-pole circuit breaker. What it is single pole, what it is 3-pole, I'll tell you. Suppose if there are 3 phases here, a 3-pole circuit breaker will be like this. Means this is a 3-pole CB. Whenever fault occurs on any one of the phase, all 3 phases will be removed. Whenever fault occurs on any one of the phase, this 3-pole circuit breaker, what it will do is all 3 phases it will disconnect along with the faulty phase. Then what happens with this 3-pole circuit breaker? PA is equal to PS minus PE will be entirely 0. That is equal to PS. Why? All three phases are disconnected. This is phase A, B, and C. This is 3-pole circuit breaker. How a single pole circuit breaker looks? Yes, I'll show you here how a single pole circuit breaker looks. Yes, observe, this is phase A, this is phase B, this is phase C. It is going to have circuit breaker A, circuit breaker B, circuit breaker B, C. This is a single pole circuit breaker, phase A, B, and C. So here in this, what happens is whenever fault occurs on phase A, only phase A will be disconnected. PA is equal to PS minus PE of phase B plus PE of phase C will be there. This is not equal to 0. There is some, means this is less when compared to the previous one. Previously, yes, this entire electric power output is 0, therefore PS is very, very high. PA is very, very high. Here, PA is not that much high. Rotor acceleration will decrease. System will be more stable when compared to the previous one. This is also one of the very good method. We are using single pole circuit breaker instead of 3-pole circuit breaker. These many methods are there to improve transient stability. Thank you.